You're looking live at the ILS Proton launch vehicle on Launch Pad 39 at the Baikonur Cosmodrome in Kazakhstan with the Inmarsat 5 F3 satellite on board. Today's liftoff is scheduled for 5:44 p.m. in Baikonur, which is 12:44 p.m. at Inmarsat headquarters in London, 7:44 a.m. here at the ILS Broadcast Center in Washington, D.C., and 4:44 a.m. at Boeing Satellite Systems International in El Segundo, California. Here's more about Global Express in this video provided by Inmarsat, followed by a special greeting from Baikonur.
People aren't using their landlines in their homes anymore. And there are so many things we do now, remotely, on the move, untethered. It's really quite extraordinary.
What makes a human being, among other things, is the ability to communicate.
Wherever you travel, wherever you go, the expectation that you are connected.
It's changing the way we live our lives, the way we communicate, the way we have friendships, the way we get our job done. And Inmarsat is part of that.
Rupert Pearce is the CEO of satellite communications company Inmarsat, a company with a compelling vision of the future. A future in which we're all connected, everywhere.
Inmarsat has been a leader, in fact the leader in mobile satellite communications for more than 35 years. We were founded all those years ago by 86 countries who signed a convention on safety of life at sea. And that, for the first time, began to use satellite technology in a unique way for things that moved. So that was the genesis of Inmarsat. So we can deal with ships in the oceans, we can now deal with aircraft flying at over 600 miles an hour. And of course, if you can do that, you can also deliver services on the ground as well.
Inmarsat's global communications coverage provides voice and data links using a network of satellites 35,000 kilometers above the Earth in geostationary orbit. Their services underpin industries and endeavors that require highly reliable connectivity in the remotest places and the toughest conditions. What Inmarsat have created is an internet of everywhere.
We have that culture of taking it forward. When you want to provide a data service, a voice service in the middle of the Pacific, in the middle of the Sahara, in the middle of the Indian Ocean, whatever that may be, you need to stretch that space technology.
The next big stretch for Inmarsat is one that could transform the business and change the way we live our lives. Michele Franchi is Inmarsat's Chief Technology Officer and the man responsible for building the next generation of high-speed satellite broadband. It's a project bringing together experts all over the world, taking years of preparation and $1.6 billion of investment by Inmarsat. The new network is called Global Express.
So GX is actually about giving easy, thoughtless, seamless access to broadband quality communications wherever you are, to professional or individual users, to passengers on a ship, to crew members on a ship, to passengers on an airplane, to journalists in the field, to servicemen and women in the armies and the navies of the world.
To achieve seamless coverage, Global Express uses 3 state-of-the-art Inmarsat 5 satellites, placed 35,000 kilometers from Earth, each covering a region of the planet at higher speeds than ever before.
Global Express is a revolution for Inmarsat and for our customers. For the last 35 years, we've been working in the L-band, but there isn't enough bandwidth there for us to be able to deliver really high throughput, high capacity services.
We looked at what we had on L-band and we saw that we're reaching its limits in many aspects.
So we've moved strategically into a complementary band, the Ka band. The most important thing about Ka band is it allows us to deliver very, very high levels of throughput.
We needed to go to another band. We need to do something different.
Global Express was an incredibly brave decision by the board, which was to rip up the playbook, start again.
But Inmarsat couldn't do it alone. To design and build the Inmarsat 5 satellites for the backbone for the GX network, Inmarsat chose air and defense manufacturers Boeing. Network experts iDirect would provide new technologies to drive the mobile terminals and globe-spanning ground network, while IT giant Cisco came on board to create a new delivery platform for services and applications. A project on a massive scale to enable humanity to live more connected lives wherever they choose.
We all have this compelling need of exchanging, of exchanging services, thoughts, goods. What makes a human being, among other things, is the ability to communicate. And it's because we all have this compelling need that the world moves on and we have developed all the wonderful things that we have in the history of humanity.
Landing a man on the moon and returning him safely to the Earth.
We used to communicate to people that were in the same village as us and then in the same region, and then we went further and further. We started having explorers taking ships and sailing the oceans to see what was at the other end of it, and then we had airplanes. There was a time when writing a letter was enough, but today's world is a world where we cannot afford that speed or lack thereof. The big shift that we are assisting in the telecommunications world is everything that you can possibly think of in a mobile environment, in a world where people move all the time. That sort of puts us in a pole position, which doesn't necessarily mean you'll win the race, but it does make it easier than if you start from the last row.
So this is part of our lab. This is the GX rack, where we have recreated a mini test bed for us. So typically what you have here, for example, are the iDirect core modules, which represents what's in our terminals.
Xuan Wang has been at Inmarsat for over 20 years. As the man running the engineering team on GX, Xuan's daunting task is to make this incredibly complicated operation run smoothly.
You know, it's just like the analogy is that a swan is sort of gliding across the lake and we're busy pedaling underneath. At each stage, there are challenges, but we knew that we did the right thing, and through hard work and experience, we've got there. But I think for most of the team, is the excitement of getting to there that keeps us going.
It's been a very busy time at Inmarsat over the last 10 years, but of all those things, clearly the most transformational event in my Inmarsat lifetime is Global Express. There's absolutely no question about that.
The coming months will be a key time for Inmarsat as they launch the third satellite in the I-5 Global Express constellation and bring the global network into commercial operation.
We know GX does what we hope it will do. We look outside into the markets that we serve and we see that Global Express is still, 5 years from its genesis, is still revolutionary. It's still what people want.
It will be still a lot of challenges ahead of us, but exciting times.
In Churchillian terms, this is just the end of the beginning. This is a chance for us to be at the forefront of our industry for a generation or more.
In the next film, we'll be following the story of the I-5 F3 launch and exploring a concept that will change the way we live, work and travel. The Internet of Everywhere.
You spend years making the business case, procuring, designing, manufacturing, testing, creating the ground segment, putting the antennas in place, the data communications network, making sure that the satellite is right. You do all that and you put it on top of a rocket that is essentially very solid 70s technology, but it is glorified intercontinental ballistic missile with solid boosters. The trick with solid boosters is that you just light that fuse and then it goes. You know, we are almost there. When you can see the finishing line, you get that anxiety, butterflies in your stomach.
Good morning, good afternoon to all. Here we are again, impatiently counting the hours that still separate us from the launch of the third Inmarsat 5 F3 satellite. It's been a long journey that started almost exactly 5 years ago as the ink dried on the Boeing contract for the first 3 Inmarsat 5 satellites. With its 700 tons of mass, an Inmarsat 5 F3 will climb to orbit, thus allowing the completion of the GX global coverage and the delivery of fast, reliable broadband connectivity to just about anywhere around the world, and with the level of quality that we're used to at our homes and offices. So many teams have been working all over for these 5 years through difficulties and successes on the satellites, on the launchers, on the network, the access platform, the products and the terminals. And so many others will now benefit from the services that have been developed thanks to all this effort. And so it's with a deep emotion and a real sense of pride for having been leading such a wonderful and dedicated team that I would like to thank once again the engineers and the technicians from Boeing, from Kurinchev, from ILS and from Inmarsat for having taken us so far. So go Global Express, go Proton, go Inmarsat.
Welcome to today's coverage of the launch of Inmarsat 5 F3. We'd like to welcome viewers joining us from Inmarsat offices and partners from around the world. I'd also like to say a special hello to my colleagues at Inmarsat headquarters in London who are watching now. I'm Karen Monahan, Director of Communications at ILS, and with me once again is Jean Palme, Vice President of Programs, Operations, and Chief Technical Officer for ILS. John has worked on over a dozen launch campaigns from Baikonur and has co-hosted many of our launch broadcasts. So welcome, John.
Thanks, Karen. It's great to join you here in the Broadcast Center for today's launch, the third and final satellite required for the Inmarsat Global Express network. Now, we're getting pretty close to launch time, and the most recent weather readings are within the Proton mission design for launch. Preparation for today's mission started about 3 years ago with the building of the satellite and the mission integration and planning for launch on this ILS Proton. Mission teams are in their places in the launch bunker, control rooms, ground stations, and communication centers that are around the world, and the final go for launch polling has been completed. In addition to those in the Baikonur Cosmodrome, there are many others who have played an important role in the Inmarsat 5 F3 mission. We'd like to say thanks for all your hard work in getting to this moment. That includes the Inmarsat employees in London and their regional offices around the world, hardworking professionals at Boeing Satellite Systems International, Kurinchev employees in Moscow and other regions of Russia, ILS headquarters in Reston, Virginia, and many, many others who have helped make today's launch of Inmarsat 5 F3 a reality. We're about 30 seconds from launch at this point. You can see the vehicle erect there on the launch pad. It's a beautiful clear sky today, daylight launch. We're about L-15 now. And T-10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And we have ignition. And liftoff. Liftoff of an ILS Proton from the Baikonur Cosmodrome in Kazakhstan with the Inmarsat 5 F3 satellite on board. About 10 seconds after liftoff, the vehicle does do a roll maneuver, which aligns the launch vehicle pitch axis with the northeasterly launch azimuth. And the vehicle will soon experience maximum dynamic pressure, or max Q, which is the maximum aerodynamic stress on the vehicle during flight. Beautiful shot there as the vehicle climbs the hill, as we like to say. For Proton, max Q occurs about 1 minute and 2 seconds after liftoff at a velocity of Mach 1.6, and it's sometimes accompanied by a visible condensation if atmospheric and lighting conditions are favorable. Lost video there, but we have a simulation running. Everything seems to be proceeding nominally as the vehicle ascends over the Cosmodrome in a northeasterly direction with a flight launch azimuth of approximately 61.3 degrees. We're about 90 seconds now since launch. And we're coming up on the first stage separation from the second stage, and that's set to occur at about 2 minutes into the flight. On clear days, the observers at the Baikonur Cosmodrome may be able to see a bit of a halo effect of light as the second stage engines ignite prior to the separation from the first stage. Coming up on 2 minutes after launch. And the simulation running, we should have passed the stage 1-2 separation. I have confirmation of ignition of the second stage and good separation from the first stage. Now at this point, all 4 engines on the second stage should be firing. Second stage will operate for about 3 minutes and 27 seconds. The next key mission milestone will be the separation of third stage from the second stage at L plus 5 minutes and 27 seconds. Now, 20 seconds after that event, the payload fairing pyros will fire, which will separate the 2 halves of the payload fairing and jettison them from the vehicle. Lastly, as the ILS Proton travels northeasterly downrange from Kazakhstan into Russian territory, our viewers may notice some brief planned time lags in our reporting of key mission milestones, as the telemetry has to be relayed from multiple downrange ground stations.
And the first burn of the BRIES-M upper stage is scheduled for completion about 16 minutes into the flight. And our live coverage will conclude after that burn, since the rocket will be out of range of our tracking stations as planned. Boeing 702HB spacecraft provide new Ka-band global high-capacity satellite services to Inmarsat, the leading provider of global mobile satellite communication services, and leverages Boeing's extensive expertise in Ka-band satellite communication systems. Here's more about the manufacturing of Inmarsat 5F3 in this video provided by Boeing.
Since the launch of CENTCOM in 1963, Boeing has developed many different families of satellites, the largest of which is the 702HP platform. By comparison with CENTCOM, which was roughly 3 feet across, the 702HP, when fully deployed, has a tip-to-tip span equal to that of a Boeing 737.
Our design is leveraged off the 702 technology that we have 21 spacecraft in orbit flying right now and 9 more in production in the factory. And similarly, we have a lot of experience on the Ka-band payloads. Over the last 20 years, we've been involved in developing Ka-band systems.
The Inmarsat 5 Global Express system will deliver mobile connectivity of up to 50 megabits per second of broadband data and communications. Each satellite has a pattern of fixed beams on the Earth, augmented by steerable beams that allow Inmarsat to address capacity hotspots as they arise.
The beauty of Boeing and the development of the Inmarsat 5 program is that it's all really happening under one single roof in El Segundo. So a lot of suppliers produce hardware for us, but it all gets integrated into the integrated satellite factory.
We have a great team, a combined team. Boeing and Inmarsat have worked together developing this complex system.
What I really like about the program is getting a chance to work with the Inmarsat customer and leveraging the technology that we've established over many, many years.
It's exciting to have partnered with them to develop this very powerful and capable satellite.
ILS launched the first of 3 satellites in the Global Express series, the Inmarsat 5F1 satellite on December 8, 2013. Inmarsat 5F1 entered commercial service in July 2014 and provides regional Inmarsat Global Express services for Europe, the Middle East, Africa, and Asia. ILS also launched the second of the Global Express series, Inmarsat 5F2, on February 1st of this year. The satellite is currently serving Inmarsat customers in the Americas and the Atlantic region. Inmarsat 5F3, which just lifted off from Launch Pad 39 at the Baikonur Cosmodrome, is the final satellite required to complete the Global Express constellation, providing coverage over the Pacific Ocean region. Global Express will deliver seamless, globally available high-speed broadband connectivity on land, at sea, and in the air, provided by one single operator.
Today's launch is the 405th Proton launch overall since Proton's first flight in 1965 and the 90th ILS Proton launch. It is the third ILS Proton launch of 2015 and the fifth ILS commercial super-synchronous transfer orbit mission. The satellite operator for today's launch is Inmarsat, headquartered in London, England. This is the fifth Inmarsat satellite launched aboard Proton. Satellite manufacturer for Inmarsat 5F3 is the Boeing Satellite Systems International Corporation with its major manufacturing location in El Segundo, California. This is the 19th Boeing satellite launched on an ILS Proton.
We're now coming up on some key milestones. So, John, what can you confirm?
So I just got confirmation from Judy Opp at our Baikonur Communications Center that the stage 2 separation has occurred on schedule. Also, at 20 seconds after that, the payload fairing did jettison as well. So the third stage is currently operating. Now, the payload fairing jettison occurs at a relative velocity of about 4,600 meters per second, or about 2.9 miles per second, at an altitude of about 137 kilometers. Our next major milestone happens in just a few minutes, and that will be the completion of the third stage engine operation, followed by the separation of the Breeze-M upper stage with the Inmarsat 5 F3 spacecraft. The ILS Proton mission design for the Inmarsat 5 F3 satellite will utilize 5 burns of the Breeze-M upper stage to place the spacecraft into a super-synchronous transfer orbit. And we engineers like to turn everything into acronyms, so we frequently refer to this mission design as SSTO, and will take 15 hours, 31 minutes from liftoff to satellite separation and insertion into the planned super-synchronous transfer orbit. Now, let's take a look at the Inmarsat 5 F3 mission profile. The following is the description of the super-synchronous mission flight profile of the ILS Proton launch vehicle with the Inmarsat 5 F3 communications satellite on board. The first 3 stages function to propel the orbital unit to a suborbital trajectory. The orbital unit consists of the Breeze-M, payload adapter system, and the Inmarsat 5 F3 satellite. The sequence starts with the ignition of the powerful first stage engines that output 2.4 million pounds of thrust at sea level. As the ILS Proton lifts off from Launch Pad 39, it immediately executes a roll maneuver to align its flight launch azimuth to 61.3 degrees in order to achieve a parking orbit inclination of 51.5 degrees as it travels in an east-northeast direction across Kazakhstan toward the Pacific Ocean. The engines fire for about 2 minutes, during which time the ILS Proton experiences maximum dynamic pressure. Then, the first stage separation occurs. The second stage engines follow with nearly 540,000 pounds of thrust for 3.5 minutes, and then the third stage engine fires with 131,000 pounds of thrust for 4 minutes. The payload fairing is separated soon after third stage ignition, high above the Earth's dense atmosphere. At stage 3 separation, the orbital unit has traveled from Baikonur to Russia near the eastern edge of Kazakhstan at 51.5 degrees north latitude, and is moving about 7,300 meters per second, or 4.5 meters per second relative velocity. The upper stage of the ILS Proton rocket is called the Breeze-M and is designed to inject payloads into a wide variety of target orbits. There are 5 Breeze-M burns in this SSTO mission design. The first Breeze-M burn occurs about a minute and a half after the third stage separation, when the orbital unit is still in a suborbital trajectory. This will last long enough to achieve a low Earth circular parking orbit of 173 kilometers. This 4.5-minute burn spans from Siberia to Russia's east coast. 1 revolution later, and about 1.5 hours after the first burn main engine cutoff, the second Breeze-M burn occurs. The resulting elliptical orbit is called the intermediate orbit, and increases the apogee to 6,000 kilometers, the perigee to 295 kilometers, and decreases the inclination to 51 degrees. This 19.5-minute burn spans from the southern tip of the Japan island chain to 600 miles northeast of New Zealand. 2 hours, 14 minutes after the second burn, the third Breeze-M burn starts. Soon after this burn shuts down, the depleted auxiliary propellant tank is jettisoned and the fourth Breeze-M burn begins. The resulting orbit is called the transfer orbit, where the apogee is greatly increased to supersynchronous altitude of 65,000 kilometers. These two burns add up to just over 20 minutes and span from northwest India to Australia. During the coast phases, the BRIES-M performs attitude maneuvers in order for Inmarsat 5 F3 solar rays to be exposed to the sun at a predetermined solar illumination angle, which is designed to satisfy its thermal and power requirements. 10.5 hours later, during the fifth and final BRIES-M burn, the orbital unit will perform a large plane change maneuver from 51 degrees to 26.75 degrees inclination in a 3.5-minute burn. The fifth BRIES-M burn and ensuing spacecraft separation occur high over Papua New Guinea. About 12.5 minutes later, the Inmarsat 5 F3 satellite is separated from the BRIES-M to reach its targeted supersynchronous transfer orbit. The total mission time from launch to Inmarsat 5 F3 spacecraft separation is approximately 15 hours 31 minutes, and the total travel distance is approximately 3.5 times the circumference of the Earth. F3 satellite completes its in-orbit testing period. The satellite and its 89 Ka band beams, along with the other two Global Express satellites, will provide flexible global coverage from their operational locations in geosynchronous orbit.
So John, what is the current status of the mission? Any updates from Baikonur?
We have confirmation of stage 3 shutdown and the separation of the BRIES-M from the Proton third stage, so that's all good news. The BRIES-M will now begin preparations for the first of 5 ignitions of the main engine, and we also have confirmation of the main engine start of the BRIES-M. The duration of the first burn of the BRIES-M is planned for 4 minutes and 27 seconds. Now this will inject the BRIES-M with the Inmarsat 5 F3 satellite into a circular parking orbit with an altitude of 175 kilometers and an inclination of 51 degrees.
Now here's a message from Bertrand Moncouquet, ILS Program Director, recorded earlier in Baikonur.
Hello, I'm Bertrand Moncouquet, the ILS Program Director for Inmarsat 5 F3. And I'm glad to tell you that we have had a very, very smooth launch campaign with a very beautiful month of August, and today is the first day with some clouds. First of all, I want to thank Inmarsat for the confidence they give us to go back to the flight with Inmarsat 5 F3. And I want to thank all my teams and all our colleagues' teams, particularly the Russian, because there was a lot of work to do for this return to flight. Then let's go again, and go Proton, go BRIES-M, go Inmarsat 5 F3.
So John, what can you tell us about what happens with the Inmarsat 5 F3 satellite after Proton places it into its transfer orbit?
Well, our broadcast takes us through the first BRIES-M burn. After the broadcast completes, the BRIES-M will execute 4 additional burns before separating the spacecraft into the planned supersynchronous transfer orbit at about 15 hours and 31 minutes after liftoff. The ILS Proton will have completed the mission of transferring the satellite from the surface of our planet into an orbit with an apogee of 65,000 kilometers, or about 40,000 miles. Inmarsat and their contractors will take over telemetry, tracking, and control of the satellite from that point forward. The satellite will then execute a series of planned operations over the next several days. Now that's going to include things like solar array deployments, antenna reflector deployment, and a series of orbital maneuvers. These maneuvers will decrease the orbit inclination to 0 degrees, raise the perigee, and decrease the apogee, ultimately resulting in a circular geosynchronous orbit over the equator. Following a period of in-orbit testing, the satellite will then operate in geosynchronous orbit to provide, along with Inmarsat 5 F1 and F2, flexible global coverage for Inmarsat and its customers.
Now a greeting from Mikhail Yakimchikov, Krunichev Program Director.
We are completing the launch campaign in Inmarsat 5 F3. The ILV consisting of Proton-M, launch vehicle BRIES-M upper stage and Inmarsat 5 F3 spacecraft is verticalized at the launch pad. Everything is now ready for launch. Very soon we'll have a constellation of 3 Inmarsat satellites that were injected into orbit by Krunichev Space Center. It was not easy to prepare for this launch due to professionalism, tolerance, and certainly friendship of the participants of the campaign. The Inmarsat constellation is becoming a reality. I wish all the best to all the specialists who contributed to this launch, as well as to their families. Thank you a lot, and let us meet again at Baikonur.
The launch site for Proton missions is the Baikonur Cosmodrome, which is rich in space history. Let's take a closer look at the launch facility. The Baikonur Cosmodrome is the world's first and largest operational space launch facility and has been in operation since 1955. It's located in the desert steppe of Kazakhstan, approximately 2,100 kilometers or 1,300 miles southeast of Moscow. The Cosmodrome is a large complex that extends about 100 miles from east to west and 55 miles north to south, which is about the size of Holland. Under Roscosmos, the Russian Federal Space Agency, Baikonur remains a busy spaceport with numerous commercial, military, and scientific missions being launched annually. The Baikonur Cosmodrome is under a long-term lease from the Republic of Kazakhstan. Today's ILS Proton will launch from Pad 39 in Area 200, one of the 3 launch pads available for Proton launch use. As John indicated through communication with the Baikonur control room, this is the point in the mission now where the BRIZM upper stage is just getting started, and a total of 5 burns will be required before we get to spacecraft separation. So John, what is the current status?
Well, the Communications Center is reporting that the mission is nominal and that the orbital unit is traveling along the planned flight path. And I can now confirm that the first BRIZM burn has been completed. A few minutes from now, the BRIZM, along with the Inmarsat 5 F3 satellite, was going to enter a planned communication blackout period. This is when the vehicle is out of range of any of the designated BRIZM tracking stations. The mission will be back in communication after the second burn of the BRIZM is complete, about an hour from now. At that time, the BRIZM will then download all its stored telemetry data, which will then be routed back to Moscow and Baikonur.
Representing satellite manufacturer Boeing Satellite Systems International is Program Manager Stephen Schmidt.
I'm very proud to be here today representing the thousands of men and women from Boeing who built and delivered the F3 spacecraft. Thank you for your dedication, your hard work, your technical excellence, and I know that you built F3 with a lot of pride. This launch is the culmination of years of shoulder-to-shoulder partnership with the Inmarsat team, led by Franco Carnevale, Inmarsat Vice President of Satellites and Launch Vehicles. Through the years, we've encountered many tough technological challenges, but we've always overcome them and had many, many more successes. We've really built and delivered a great spacecraft, Franco, you and your team. This has been a very smooth campaign, and I'd like to thank our teammates at Krunichev, Roscosmos, Sinki, and others, and especially the hardworking people at the International Launch Services. This is a great moment in the continuing partnership between Boeing and Inmarsat. And as Yuri Gagarin said in 1961, as he was about to lift off from the very Baikonur Cosmodrome here, Poyechali, let's go, Inmarsat 5 F3.
You can keep current on the Inmarsat 5 F3 mission by visiting the ILS website, which is ilslaunch.com, the Inmarsat website, inmarsat.com, by following us on Twitter, or by liking us on Facebook. Also, at ilslaunch.com, you can check out past pictures of past missions, read blog posts from the ILS mission team, and view past liftoff highlights and full broadcasts. I'd like to thank Jean-Paul May for co-hosting the broadcast with me today and for all of his mission updates. Thanks a lot, John.
Thanks, Karen. It's a pleasure to co-host the launch of Inmarsat 5 F3 with you.
So this concludes our live coverage of the ILS Proton launch of Inmarsat 5 F3 satellite for Inmarsat. Before we go, here's another look at the beautiful taillight launch of Inmarsat 5 F3 aboard an ILS Proton from the Baikonur Cosmodrome in Kazakhstan. On behalf of the ILS team and all of our partners and customers worldwide, we thank you for watching.